Some key skills we're going to cover in this video are how to calculate how many bonds an atom can form and how those bonds are oriented around that atom. To learn how to calculate the number of bonds an atom forms, we are going to use three examples. The three examples we are going to use are carbon, oxygen, and hydrogen. Let's start by looking at the element carbon. Carbon is in group 4 of the periodic table. That means it has 4 electrons in its outermost shell and needs 4 more to fill it up. That means carbon is going to form 4 bonds. Those bonds can be oriented in quite a few different ways. I will cover bond orientation later. Next, let's look at oxygen. Oxygen is in group 6 of the periodic table and so has 6 electrons in its outermost shell. This means it needs 2 more and will form 2 bonds to fill up its outer shell. These bonds again can be oriented in different ways. I will cover bond orientation later. Finally, let's take a look at hydrogen. Hydrogen only has 1 electron in its first shell. It doesn't have any other shells, and so to fill up its first shell, it needs 1 more electron. Therefore, it forms 1 bond. So far, we've covered how many bonds an atom needs to form. It's time to check your knowledge by doing the following: chlorine and neon. Pause the video so that you can try this yourself, and then I will show you the answer. Chlorine is in group 7 of the periodic table. This means it has 7 electrons in its outer shell and needs 1 more to fill it up. Therefore, it forms 1 bond. An example would be Cl2, where 1 chlorine is bonded to another, or HCl. Neon is in group 0 of the periodic table. This is also known as group 8. It has 10 electrons in total, so 2 in its first shell, and then 8 in its outermost shell. Because it has 8 electrons in its outermost shell, it doesn't need to form any bonds, so it doesn't form any. Neon is therefore very unreactive. In fact, it doesn't react with anything at all. Now let's look at how bonds are oriented around atoms and how we can represent this by using something called displayed formulae. Let us look at an example of how carbon forms 4 bonds and how they can be oriented around carbon. First of all, carbon's in group 4 and forms 4 bonds. These 4 bonds can be oriented around a carbon atom in quite a few different ways. We're going to have a look at all of the different ways that these can be arranged. The way in which the bonds around carbon can be arranged depends on what it's bonding to. For example, it might be bonded to 4 different hydrogens, and so would be arranged like this in methane. Methane is also known as natural gas. Have a look at the diagram I am drawing on this board. Can you spot what's wrong with it? Pause the video and have a go. The first thing we must notice is that this carbon atom is not forming 4 bonds as expected. It's forming 5. This is impossible. We can also see a hydrogen over here which can only form 1 bond but seems to be forming a double bond. This is incorrect. Carbon can also arrange its 4 bonds by using double bonds. A good example is in carbon dioxide, where the carbon atom is bonded to 2 oxygens using double bonds. Other options include compounds that look like this, where carbon's forming a double bond to an oxygen, but single bonds to other atoms like chlorine and hydrogen. The final option is to form a triple bond to one atom, and then a single bond to another. A good example is the alkynes. So these are the ways in which carbon can have its 4 bonds arranged around the central atom. Time for another knowledge check. Try and draw diagrams to show how the bonds in the following compounds are arranged. Pause the video and try these yourself, and then check the answers. First, let's look at NH3. The nitrogen is in group 5 and can form 3 bonds. These 3 bonds can be arranged in different ways. The hydrogen, on the other hand, can only form 1 bond. There's only one way to arrange that bond. So the correct answer can only be a nitrogen bonded to 3 hydrogens, as shown by the formula NH3. Now let's look at methanol. Methanol has 3 elements: carbon, hydrogen, and oxygen. It has 1 carbon, 4 hydrogens, and 1 oxygen. Carbon's in group 4 and so forms 4 bonds. Hydrogen only forms 1 bond. Oxygen is in group 6 and forms 2 bonds. There is only one way for this to work. The carbon has to be bonded to 3 of the hydrogens on its own. If you attach the 4th one, it wouldn't work because the oxygen needs to form 2 bonds, and so the extra hydrogen has to be bonded to the oxygen at the end. To check this, we can see the carbon's got 4 bonds, each hydrogen has 1 bond, and the oxygen has 2. This type of diagram, showing all of the atoms and all of their bonds, is called a displayed formula. So in this video, we have covered the following skills: how to work out the number of bonds an atom forms, and how to work out how those bonds must be oriented around that atom. If you found this video useful, please give the video a like. And if you'd like to see more content from us, then subscribe to the channel. Thank you very much. This has been a pleasure.